Our next display is a histogram. A histogram is a special type of bar graph, and on the y-axis it displays frequency, or how often the data value occurs. There are three different types of histograms, meaning three different ways generally that a histogram can look. One is if you have a uniform histogram where all of the bars are about the same length. It tells you that each interval has about the same amount of data. Then you can have a symmetric histogram. This is where the bars are taller in the middle and shorter off to the outside. It's also called a normal curve. Or the histogram can be skewed. What that means is the bars are taller on one side and shorter on the other. Like a back-to-back stem and leaf plot, we can create a comparison histogram, so we see two sets of data on the same set of axes. And in order to create a histogram, you need a frequency table. And this is where you kind of tally how many values fall into each interval. Before we learn how to create a histogram, we're going to learn how to interpret and analyze the data in the histogram by looking at the shape. We're going to tell whether the shape of each histogram is uniform, symmetric, or skewed, and what that says about the data. Our first graph, we have the bars starting tall and then getting shorter. This is an example of a skewed histogram. And what it means is that the majority of the data, in this case watching TV, the majority of the people watch from 0 to 11 hours of TV, and very few people watch more TV per week than that. Example B, we're looking at the heights of cherry trees. And what I notice is that the bars are taller in the middle and shorter on the outside. This is an example of a symmetric histogram. And what it means is that the majority of the data is in the middle and there's fewer data on the outsides. In our case, the majority of the trees are from 70 to 80 feet tall. And then we can say a few are shorter and a few are taller. Our final histogram, we're looking at kind of a random number generator and how often each number came up. Notice all of the bars are about the same height, so this is an example of a uniform histogram. Now notice they're not exactly the same height, but across the board they're generally in the same range. So what this means is that the data occurred about the same amount of times. Another way to say that it occurred about as often as the other data values is that it occurred at a similar frequency. Frequency is how often the data value occurs. Next, we're going to take a look at creating a comparison histogram. So we have two brands of batteries, and we have the life of each battery, how many hours you can use the device that you put the battery in. Your first job when creating a histogram is to create a frequency table. What you need to do is determine the size interval you want to show the detail in the data. For battery 1, it lasts anywhere from 9 to 22 hours. For brand 2, it lasts anywhere from 8 to 25 hours. When you create your interval, it needs to be the same interval for both brands, so you have to take both values into account. Brand 2 ended up having the lowest and the highest value, so we'll use that to generate some of our intervals. When choosing an interval, it's important to make the interval small enough to show detail, but not so large so that all of the data is lumped together. In this case, I decided on intervals by 3 hours. Initially, I tried out 5 hours of intervals, but we had a lot of the data lumped in one interval and it didn't show enough detail. So I started with the lowest data value of 8, and 3 hours of intervals would be 8, 9, and 10. Then we would have 11, 12, and 13, 14, 15, and 16. Notice none of my intervals overlap. So I didn't go 8 to 10, 10 to 12, 12 to 14, because when you have a data value of 10, would it go in the 8 to 10 interval or the 10 to 12 interval? People reading your histogram wouldn't know where that data is. So it's very important that those intervals don't overlap. 17, 18, 19, 20, 21, 22, and 23, 24, 25. Our intervals go from the lowest data value we had, which was 8, to the highest data value we had, which was 25. Again, those intervals need to be exactly the same for brand 2. And then we tally how many data values fall into each category. Starting in order, we have a data value of 12, so I will tally that for brand 1. 9, 1, 2, 3, 4 tallies for 10. 14 has 2 tallies. 11, 18, 21, and 22 end up in the same interval. For brand 2, we have a tally of 13, 2 tallies of 15, tally of 12, 10, 8, 25, 17, 16, 14, 18, and 11. We will use our frequency table to create our histogram. Starting off, we will label across the bottom those intervals we just created. There's 2 different ways to label your intervals. One is to put 8 to 10 on the bottom. That is the actual interval. Another way is to label just the left endpoint. Our first left endpoint was 8. The next left endpoint was 11. So it's that first value in each of your intervals. It's important that you space each interval about the same so that skinny bars and fat bars don't end up on the same histogram. You want all of your bars to be about the same width. Across the left-hand side, we're going to list the frequency. When we look at our frequency tables, the highest frequency was 5. That was the most tallies that we had in any category. So we need to go up to 5 on our y-axis. Again, spacing those y values very similarly. And then we create the bar in each interval. Remember, we're going to have 2 bars in each interval, 1 for each brand. So when you start off with your first bar, make sure you make it half as wide as your first interval. For brand 1, we first had a tally of 5 in the 8 to 10 range. So we go up to 5. For brand 2, we first had a tally of 2 in that 8 to 10 range. The 11 to 13 range, we had a tally of 2 for brand 1. And we had a tally of 4 for brand 2. Our next interval, we had a tally of 2 for brand 1. And a tally of 3 for brand 2. In the 17 to 19 range, we had a tally of 1 for brand 1 and 2 for brand 2. We had a tally of 2 for brand 1 in the next interval and 0 for the brand 2. In a histogram, your bars should be touching unless there's no data. So I will not draw a bar for brand 2 in this interval, and I will not draw a bar for brand 1 in the next interval because the 23 to 25 range didn't have any data for brand 1. So jumping over to the second half of the interval, I will have a bar of 1 for brand 2. To make your histogram easier to read, it's helpful to shade in each bar. In the interest of time, I'm not going to on this one, but we do need to make a key. And our key is that our purple bars were brand 1, and our red bars were brand 2. Our last job is to analyze the data by looking at our histogram. What do we notice about the shape of the purple bars and the shape of the red bars, and how do they compare to one another? The purple bars started out high and then they kind of got uniform after that. The red bars seem to be skewed towards the left, but they are kind of higher in the middle and a little bit smaller on the outside. So I would say in general, both of these are skewed left. And when it is skewed left, it means most of the data is on the low side of the histogram. So it means that they both last for a shorter amount of time. However, as I mentioned, brand B tends to have higher bars towards the middle. So overall, if I were going to purchase a brand of battery based on these histograms, I have a better chance of my battery lasting longer if I go with brand 2 than I do if I go with brand 1.